Buenas tardes, hello. Hello everybody, good afternoon, boa tarde. I am Andrea Coronato. I'm researcher of CONICET-CCT out Ushuaia in Argentina. I am also one of the IAG vice presidents and the Latin American co-opter of IAG. IAG is the International Association of Geomorphologists, as you may know. Together with my colleague from Universidad Federal de Bahia in Brazil, Grace Alves, we are in charge to coordinate this fourth IAG webinar to celebrate the 2024 International Week of Geomorphology for this part of the world, for our Central and South American territories. This is an official activity of IAG, so the presentations and some lectures must be in English. But anyway, we also use Spanish and Portuguese, our local languages, for some lectures, for questions, for comments. So please feel free to participate in any of the three languages. All of them are accepted. Buenas tardes a todos, ahora en español por las dudas. Soy Andrea Coronato, soy investigadora de CONICET en el CADIC, en Ushuaia, y una de los vicepresidentes de la Asociación Internacional de Geomorfólogos, más conocida como IAG o IAG, y además soy representante para Latinoamérica de esta asociación. Y hoy, junto con Grace Alves, mi compañera de la Universidad Federal de Salvador de Bahía y secretaria de la Unión de Geomorfología de Brasil, estamos encargadas de organizar y de llevar adelante este cuarto webinar para celebrar la Semana Internacional de la Geomorfología del año 2024. Esta es la cuarta oportunidad en que nos reunimos en esta primera semana de marzo para realizar esta actividad. Les decía que como es una actividad oficial de IAG, el idioma oficial es el inglés. Por eso abrimos la reunión hablando en inglés. Pero de todos modos podemos hablar en español, en portugués, y les pedimos a todos que por favor se sientan libres de hacer preguntas, comentarios en cualquiera de los tres idiomas, porque todos son aceptados. Grace?
Boa tarde. Boa tarde a todas e todos. Eu sou a Grace Alves, sou professora na Universidade Federal da Bahia, sou secretária da União de Geomorfologia Brasileira e estou aqui junto com a Andrea Coronato, pesquisadora do CADIC-CONICET em Ushuaia, Argentina, também vice-presidente e representante da América Latina no IAG. Nós estamos encarregadas de dar boas-vindas a todos e todas que estão aqui assistindo o quarto webinar para celebrar a Semana Internacional de Geomorfologia. Por esta ser uma atividade do IAG, né, da Associação Internacional de Geomorfologia, nós utilizaremos o inglês em algumas apresentações. Também vamos comentar e perguntar e discutir em espanhol e português, que são as nossas línguas locais. Então, por favor, se sintam à vontade de fazer perguntas em português, em espanhol, em inglês, a que for mais conveniente, que nós iremos repassar para os jovens profissionais de geomorfologia que estão apresentando hoje, para que a gente tenha aí uma rica tarde. Andrea.
6 young geomorphologists from Costa Rica, Brazil, Chile, and Argentina, some of them living abroad or working abroad, are the protagonists of this webinar, in which they will share their results coming from postdoctoral studies or coming from their participation in research projects. We want to deeply thank to all of them. 6 geomorfólogos de Costa Rica, de Brasil, de Chile y de Argentina son los protagonistas del webinar de 2024 y ellos van a compartir con nosotros los resultados de sus estudios doctorales, postdoctorales o de resultados de los proyectos de investigación en los que están o estuvieron involucrados. Queremos agradecer profundamente. We want to deeply thanks to Raquel Granados Aguilar from Costa Rica, but living in the United States, Joao Paulo Soares de Cortés and Renata Jordan Enríquez de Brasil, a Ignacio Ibarra Cofré de Chile, aunque viviendo en el Reino Unido y trabajando en Reino Unido, y también a Mariana Correas González y a Damián Groch, ambos de Argentina. A todos les agradecemos ser parte de esta actividad. We are very thankful to all of them to accept to be part of this activity.
Teremos, então, 6 profissionais em geomorfologia dos países Costa Rica, Brasil, Chile e Argentina, alguns destes vivendo e trabalhando fora da América Latina, que vão compartilhar com a gente os resultados de suas pesquisas. Gostaríamos de agradecer, então, a Raquel Granados Aguilar, da Costa Rica, João Paulo Soares de Cortés e Renata Jordan Henriques, do Brasil, Ignacio Barra Cofré, do Chile, Mariana Correas González e Damián Groch, da Argentina, por terem aceitado esse convite para fazer a apresentação de seus trabalhos hoje aqui. Muito obrigada.
We hope the dissemination of the results of their work will motivate to other young researchers, students, and professionals to discover the remaining questions about landforms and processes of the Earth's surface, and their interaction with the atmosphere, lithosphere, and biosphere, as well as with the society and its infrastructure. Also, we hope to reach the IAG intention to promote this type of meetings, useful to know each other's, and to strengthen geomorphology in our continent. Esperamos que la difusión de los trabajos de nuestros disertantes sea una fuerte motivación para otros jóvenes estudiantes, investigadores, jóvenes profesionales, para descubrir los interrogantes que aún se nos presentan cuando estudiamos o cuando nos plantamos frente a geoformas y procesos que modelan o que han modelado la superficie de nuestro planeta. Cuando nos interrogamos acerca de sus interacciones con la atmósfera, con la litosfera, con la biosfera y con la sociedad que sobre ellos habita y sobre la que implanta su infraestructura. Asimismo, también es intención de la IAG que estos encuentros sirvan para reunirnos anualmente, para conocernos, para fortalecer el desarrollo de nuestra disciplina en nuestro continente americano.
Esperamos que a divulgação dos resultados dessas pesquisas possam servir como motivação para jovens pesquisadoras e pesquisadores, estudantes e profissionais para buscar as questões associadas às geoformas e aos processos que têm modelado a superfície de nosso planeta, assim como suas interações com a atmosfera, litosfera, biosfera, com a sociedade e o espaço produzido. Assim, esperamos que essa proposta do IAG possa acontecer anualmente para que possamos conhecer e fortalecer o desenvolvimento da geomorfologia em nosso continente.
Okay, no more words. It's time to start with our first presentation, ¿no? Ya es momento de presentar a nuestra primera disertante.
Sem mais palavras, a gente passa então para as apresentações. Por favor, André. Now you see Mariana Correia González. She's geographer by the Universidade Nacional de Cuyo in Mendoza, Argentina. Her master was in Universidade Paris Diderot, Paris 7. And she's doctor in Universidade Nacional at the Universidade Nacional de Córdoba. She will present for us lake outburst flood hazards in the Central Andes of Argentina.
So thank you all for being here today, participating in this great opportunity that the International Association of Geomorphology is giving us in this webinar. My name is Mariana Correas González. I work in the Geomorphology and Quaternary group in the IAG, Argentina. And I am going to present a part of my PhD research that it's a part of my studies linked in this title, Lake Outburst Flood Hazard in the Central Andes of Argentina. So, not moving? No. Okay. So, first, oh, sorry. Lake outburst floods are floodings produced from lakes of different types that are located in high mountain areas. And they are among the most hazardous and geomorphological effective floods in high mountain areas. So according to the type of lake that gives origin to these floodings, we have glacial lake outburst floods, which are called GLOF, or landslide dam lake outburst floods that are called YOF. So this type of floodings have a very long peak discharge, total volume, and velocities that exceed those from meteorological floods. And in the extratropical Andes, in the southern part of Argentina, the southern part of South America, there is a previous work conducted by Iribarren and Acona et al. In 2015 that conclude that at least 31 lakes produced 100 GLOFs in the last 2 centuries. And in the 20th century, 200 fatalities were linked to GLOFs, and only one landslide dam lake event produced by the Carrilauken Lake in 1914 resulted in 200 fatalities in Argentina. So these processes or these events that that occur in high mountain regions are also like in link with human pressure, which is increasing in high mountain domains. So many glacial inventories, glacial lake inventories were made in the study area, but there was a gap in relation to all the type of lakes that are available in the study area. And also a complete lake outburst flood inventory was missing. And that's the gap I wanted to fill in with my research. So the study area is the Central Andes of Argentina between the 31 and 36 latitude, south latitude. It comprises the main and frontal cordillera, from which elevations that goes from 2,000 meters above sea level up to 6,000 meters above sea level, with the Aconcagua here, located in Mendoza. There are 7 major basins, and this is a total area of 34,000 square kilometers. So the climate in this area is cold and semi-arid. Precipitations are mainly related to snow in winter, and they have a steep gradient from north to south, as you can see here in the meteorograms on the right. In the north, precipitation reaches 300 millimeters in the entire year, and temperature goes from 0 to -10 degrees in average. And to the south, we have an increase in precipitations that reaches more than 700 millimeters, and also temperature goes from 5 to -5 degrees. Regarding to population and activities, in this area, there are around 2.5 million of inhabitants, which lives mostly in the cities of Mendoza and San Juan that are located here, but there are also small villages located in the mountain domain that also have hundreds of inhabitants. And also it is important, there is the important trade corridor in South America, which links all the transport between the Atlantic Ocean and the Pacific Ocean, which goes here across the Mendoza River Valley in this area. I will talk later about this specific basin. That's why I'm pointing out this situation. And obviously, high mountain attracts tourism and many recreation activities from people. So first of all, for doing my research, I needed to prepare this complete inventory of lakes. I used the normalized difference water index based on Landsat images from the year 2020 to identify the water bodies, and I did a manual mapping of each of the lakes. And then I estimate the volume of the lakes using an empirical equation proposed by Cook and Quincy. For the classification of the lakes, I used satellite images, Google Earth, and all this information put in a geographical information system. And also I conducted field work to check what I was seeing in the satellite images. And finally, for the lake stability assessment, I used classical geomorphological indices developed by, which are the dimensionless blockage index, or DBI, and the blockage index, which is the BI, developed by some authors I will comment later. And I also made a qualitative assessment of the glacial lakes. The geomorphic indices, are accurate for landslide dam lakes, and the qualitative assessment was applied to glacial lakes. All the lake inventory, the classification, and the stability assessment allows to do the hazard characterization of this lake outburst flood. So these are some of my results. This is the lake classification I did. So according to the genetic origin of the lakes, 7 main types of lakes were identified. There are glacial lakes that you can see here in the left side, moraine dam lakes, and bedrock dam lakes that will be enclosed in glacial lakes lately in the presentation. And these lakes are located in the high part of the basin, as you can see here in this schematic in the center. I also identified volcanic lakes related to lava flows and calderas, and also landslide dam lakes and karstic lakes, which are mostly in the lower part of the basins. So for the year 2020, I identified 456 lakes, which cover an area of 24 square kilometers, and they comprise a total volume estimated in 1,300 cubic hectometers. Here in the map, you can see the distribution of these lakes across the entire area, where landslide dam lakes and moraine dam lakes are more important in the basin of the north. We have a concentration of small glacial lakes here in the center of the study area, and to the south of 34 south latitude, we have all the types of lakes where there are landslide dam lakes, karstic moraine, and also volcanic lakes. So from all the lakes, glacial lakes, moraine dam lakes, and bedrock dam lakes are the more important, as you can see here in the graph on the left, important in number. and landslide dam lakes only represent the 4% of the total inventored lakes. In contrast, and regarding to lake volume, there is one huge lake that is the Laguna del Diamante, which is located here in the map, that comprises almost 88% of the total volume of the lakes in the area. And the remaining 12% is distributed, as you can see here in the bars, where landslide dam lakes are important as well as moraine dam lakes. So the historical lake outburst floods that have occurred in the area, I will present the Plomo Glove case, which is an important case because of the damages it caused in 1934 when Mendoza city was struck by this flooding. Well, there has been 6 events or 6 floodings relating to this temporary lake, which is formed when the Grande del Nevado del Plomo Glacier, as you can see here in the picture in the bottom, the Grande del Nevado Glacier is a surging glacier that when it surges, it can block the bottom of the valley and produced the formation of a temporary lake. This glacier is located here in this part of the Mendoza River Basin, and this is all the way that the flooding flows down up to it finds at 50 kilometers the first population here in Punta de Vacas, and then it continues to flow up to the localities of Potrerillo, Cacheuta, and the city of Mendoza is located here. It's away from the map. So this flood, here on the right, you can see some pictures of the damages that caused this flooding that occurred the 10th of January of 1934. Mainly all the railways were distracted, and this was the main communication transport system at that time. And this picture is from a hotel that was located here at the Cacheuta at 150 kilometers away from the temporary lake. And you can see how the terraces were eroded because of the flooding at that time. So here you have the hydrograph from the Plomo Glove, which shows that the peak discharge can reach it at that time almost 105,000 cubic meters, and the average flow of the river Mendoza in summer is around 100 cubic meters per second. So it was really important, the difference between the normal flow and the peak discharge that this flood produced. Another historical lake outburst flood was produced by the Valla Lake. This took place in the year 2001. And here you can see in the left satellite images that show the great extent of the lake located in a very small basin. And in the satellite image on the right, you can see that the extent of the lake has decreased, and that the landslide dam that is also here in the picture at the bottom was breached because of the flooding, and a huge outburst fan was produced here at the toe of the landslide dam. So the peak discharge of this flow was estimated in 1,000 cubic meters per second, and the volume of the lake outburst flood was estimated, as you can see here in the table. This is a picture that shows the former shore level of the lake on the top, and how it down to like 8 meters after the flooding. So this lake is interesting because it has a 16 years longevity, which is quite long for landslide dam lakes in general, and also because the geomorphic indices applied to the pre-geoff conditions indicate that the dam was stable. However, this landslide dam breached and the flooding was produced, and the possible cause of this outburst was the increase in lake volume due to melting of above average snowfall. Fortunately, no damages were recorded, and unfortunately, this flood didn't produce or impact in the Grande River hydrograph. So for the stability assessment of current landslide dam lakes, I assessed a subset of 19 lakes, from which 12 are originated from landslides and rock avalanches. And what I want to point out here is that according to geomorphological evidence, 6 of these 12 landslide dams have evidence of lake outburst flood. So they have produced at some point in the past, we don't know when, an outburst flood. So here in the right, you can see the results of the blockage index and the dimensionless blockage index. So mostly, in general, all the lakes are considered stable, and only the Los Erizos lake, which is here, is considered unstable by this index that relates the basin area and the volume of the dam. So the bigger the volume of the dam, it is supposed to be more stable, this lake, and the bigger the area of the basin, we suppose that more water is available to fill the lake and to produce a big lake. In the case of the dimensionless blockage index, also in general, all the lakes are considered stable, and there are some small lakes here that are considered unstable, but they are really, really small in terms of water volume of the lake. And this index consider the basin area and the volume of the dam, and a ratio between the volume of the dam and the height of the dam. So the conclusion of this slide is that Los Erizos Lake is considered unstable, and other unstable lakes imply a small volume. So the stability assessment of glacial lakes was made for a subset of 17 glacial lakes, where parameters related to the dam, such as the type of dam or the genetic material of the dam, also if there was evidence of infiltration in the dam, were considered. Regarding the lake, we consider the lake area evolution according to the previous periods. And regarding basin parameters, we took into consideration if there was a glacier in contact with the lake, the topographical susceptibility of a rock avalanche impacting into the lake, and many other factors. And what we can see is that in general, all the glacial lakes are small in size. They comprise small lakes like here, with the exception of this lake that is here in this picture at the bottom, where you can see that there is a south-facing slope that could produce a rock avalanche that impact into the lake and may produce the collapse of the lake. Also, there are debris-covered glaciers and rock glaciers in the upper part of the basin that are giving water into the system. And here, the Moraine Dam Lake is breached, and there are evidence of infiltration which we assume that is an indicator of instability. And this is another case of another lake. So here in the map, you can see the location of these different lakes according to their potential instability. So to conclude, in this research during my PhD, I conducted the first overarching lake inventory and lake classification in the Central Andes region. And the hazard associated with lake outburst floods is often ignored because of the few records and the remote location of the lakes. Even though, in general, landslide dam lakes are stable according to the geomorphic indices, with the exception of Lake Los Erizos, and Glacial Lakes Stability Assessment identified 4 lakes highly unstable and 4 lakes unstable. However, these lakes are relatively small and its hazard level depends mostly on exposure. And finally, I would like also to remark the need of monitoring these lakes and to work in collaboration with local authorities to give more importance to this topic that is frequently ignored, but that can be very highly destructive in case of lake outburst flood. So thanks for listening, and I will be glad to answer your questions if you have any.
Okay, thank you, Mariana. So we have no question in the chat. Andrea, do you have someone?
Yes. Okay. Yes. Thank you. And thank you very much for your presentation. It's very interesting and very well presented. I was wondering, in terms of basins, which basin you consider is the more risky to have these kind of problems in terms of population and cities present in down rivers.
Yes.
Do you think there is anyone that could be more risky than others?
Yes, that's a good question. And I would say that, well, in general, in this area or in this region, the cities are not so close from lakes. So it's more a problem for activities that are located in the high mountain areas, like mining or some roads that are probably the possibility to access to remote locations. Because as you can see, for example, here, when it was this event from the Plomo Lake in 1934 and also in 1985, the lake is located 150 kilometers away from the city. And even though it was able to reach this flooding, the city, and to produce many damages in the railway that was the main mean of transport at that time. Today we have this trade corridor which goes from crossing the entire Mendoza River Valley here, as you can see with my mouse. And maybe there is no a city that would be affected, but there are many people using, for example, this important road, or there are bridges that are that could be affected in the case of the flood. Also, the Los Erizos Lake, which I mentioned, and was studied by other authors from Argentina and from around the world, is also a case that is similar because it's a lake located far away, but it reaches the city of San Juan. So when we have big lakes in basins that can be from different sizes, these lakes are able to reach the cities that are really far away. But sometimes we have small lakes that could affect some tourists walking in a hiking trail, for example, or I don't know, mining activities that are located in in the mountains.
Okay, thank you. And another short one.
Yes.
Considering the Glaciar del Plomo lake
Yes.
that had several times had these glove events, it is possible to have new events during this time. And in case it is yes, is the population prepared? There are some mitigation measures for to be prepared for that process?
Yes, that's also a good question. I am not, I didn't study specifically the surging process or dynamic of the glacier.
Okay. Oh, okay.
So if we think about this glacier in the context of climate change and that all glaciers are receding in general, the front of the glacier is every time or every year is going higher on the slope. So the distance that it needs to travel to block the river is at each time is higher. So
higher, yes.
It's higher or the glacier is going farther up on the slope. So it would be necessary to have a very huge surge event to block the river. This is a hypothesis.
Yes.
So more research should be conducted to analyze the surging dynamic of this glacier. But what you ask, if population is aware about the situation, there are some people know that at some time there was a lake that produced a flooding in the city, but it's not so common. And also the time that the flooding needs to travel from this location here in this basin to the first place where there is people living. This is like 8 hours or 12 hours. So, and then to reach the city is 24 hours.
Okay.
According to the volume of the flooding, no? But is not so easy to manage a situation like that if you have the flooding of this size. But you can see that in 1985, the flooding was smaller than in the 1934 event. So maybe there won't be a very big flood, but we don't know, because maybe climate change would go in the other direction also. And the glacier, I don't know, can react or function in a different way. So there are many research needed in this area.
Okay, Mariana, thank you very much. And congratulations for your work.
Okay, thank you.